Angle bisectors. An angle bisector divides an angle into two congruent angles. The angle bisector can be a line, a segment, or a ray. In this figure, we have angle ABC, and it's being bisected by ray BD. The angle bisector theorem states that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So in this picture, if BF is the bisector, and then we know that FD is perpendicular to one side of the angle, and FE is perpendicular to the other side of the angle, then we can say that DF and FE are going to be congruent to each other, or equal. And then the converse is also true. So if we know that we have those perpendicular parts and they're equal, then we can assume it's a bisector. So we're going to use the angle bisector theorem to find the measures here. If we take a look at the first figure, we want to find the measure of xy. I see that these are perpendicular. I know that xz or zx is a bisector because these are both measures of 41 degrees, which means that these two sides, xw and xy, are equal to each other. So that means that xy is equal to xw. If xw is 7, then xy equals 7. In the next one, we want to find the measure of angle JKL. So the question is, what is the measure of this angle right here? Well, we see that we have these tick marks here saying that those are equal. We see the perpendicular, so we can assume that this is a bisector, which means that JKL, this angle, is congruent to LKM, this angle, so they should both be 37 degrees. And then in the next one, we want to know what is SP. It's kind of difficult to see, but there's an arrow pointing. This is S right here. So SP is this portion right here. Now we see these marks, which mean that it's a bisector. We see these perpendicular marks. So that means that MS and SP are going to be congruent to each other. So SP is going to be equal to MS, and we can set their measurements equal. So SP is 6x minus 7, MS is 3x plus 5. And let's solve for x and then plug it back in. So that's 3x minus 7. That means 3x is equal to 12, or x is 4. So if we want SP, we're just going to substitute in 4 in place of x. So that's 6 times 4 minus 7, so 24 minus 7 is going to give us 17. Okay. In the next one, we have that the measure of angle BAC is 38. We have that BC is 5. And we have that DC is 5. And we want to find the measure of angle DAC, so this angle right here. And we know that this is a bisector because we see that we have the 90 degrees and these are congruent because they're both 5, therefore it is a bisector. So the measure of angle DAC is going to be 38 degrees. Now we're asked to use the same image, so we're just going to erase this and start over. So we're told that the angle BAC is 40 degrees. We're also told that DAC is 40, which means that this is a bisector, because these are the same measures. And then we're told that DC is 10, so we want to find BC, which should then also be 10. So that means that BC is equal to 10. And then again, we're supposed to use the same image, so let's just erase this. And we have that AC is a bisector. We are told that. So if we know that AC is a bisector, we know two things. We know that these angles are congruent, and we know that these sides are congruent. All right, so then BC is 4x plus 8, DC is 9x minus 7, and we want to find BC. So we can set them equal to each other. 9x minus 7 equals 4x plus 8. So we'll subtract. That's 5x minus 7. So 5x equals 15, or x equals 3. And we're going to substitute that in to find BC. So BC is 4x plus 8, which is 4 times 3 plus 8. So 12 plus 8 is going to give us BC is 20. The incenter is the point of concurrency, the point where they all cross, of the angle bisectors. So the circumcenter was where the perpendicular bisectors met. The incenter is where the angle bisectors are going to meet. So we have an incenter theorem, and it says that the angle bisectors of a triangle intersect at a point called the incenter, and that is equidistant from the sides of the triangle. So whereas the circumcenter was equidistant from the vertices, the incenter is equidistant from the sides. So if P is the incenter in this triangle, then that means the measures I have marked off here, PD, PE, and PF are all going to be congruent. That's where that equidistant comes in. And we know that is the distance between the point and that line because the shortest distance is going to make that 90-degree angle. All right, so in the next it says that if J is the incenter, so here's J, then we want to find each measure. So if J is the incenter, that means that these guys in the corners and the angles are bisectors. And that means that the 90-degree segments are going to be congruent to each other. So JF is this segment right here. JF should be the same as all the rest of these, okay? But we want to actually find its measure. So if we can find one of these yellow marks, then we can find all of them. They're all going to be the same. So what I want to do is figure out, okay, do I have enough information to find them? Well, if I take a look at this mark and kind of isolate this triangle right here, I have a right triangle with a side of 12, a side of 15, and my missing unknown side, which should be the same measure as what I'm looking for. So I can use the Pythagorean theorem really to help me out here. So that's going to be 12 squared plus, we could call this x or whatever you want to call it. X squared is equal to 15 squared. So that's 144 plus x squared is equal to 225. And then when we subtract x squared is 81, which means that x is going to equal 9. So if this is 9, then this is 9, and this is 9, so my answer is 9. The next we want to find is the measure of angle JAC. JAC is this angle right here. Okay, so in order to do that, we're going to have to do a little bit of work first. Let's take a look at the big triangle before I did all this extra drawing on top of it. So let's kind of just redraw ABC. And we see that we have a bisector here, and that's 34, which means this is also going to be 34. We have a bisector here, which is 32, which means this is also 32. And then we have a bisector here, and what we want to know is this portion over here. Okay, so if we think about this, we can really think of this as the big triangle ABC, and that if these are both 32, this whole angle over here is 64 degrees. If these are both 34, this entire angle over here is 68 degrees, which means if I can find this entire angle over here, then I can just cut it in half to bisect it. So I can say 68 plus 64 plus angle A is going to equal 180. So that's going to be, let's see, 132 plus A is 180, which is going to give me that angle A is equal to 48. So that's the entire angle A, that's 48 degrees, which means half of that is going to give me 24 and 24. So the portion of the angle I'm looking for, this part right here, is going to be 24 degrees. Let's take a look at the next one. So if P is the incenter, so here's my incenter, of the triangle, we want to find these measures. So PK is our first question. So here, when we have an incenter, we know that all the ones with 90 degrees are congruent to each other, and we know that all of the angles are being bisected. Okay. All right, so if we want to find PK, kind of using similar logic as before, we can find any of those blue lines, and they are going to be the same. So I'm going to look for the one that has two measures on it, since I know they're all forming right triangles, and it's this one right here. Okay, so I'm going to look for this side. We can call it X, and that will tell me that measure for PK, because PJ, which I'm calling X, is the same length. So we have 12 squared plus x squared is equal to 20 squared. So that's 144 plus x squared is equal to 400, which means that x squared is 256, or x is going to be 16. So if x is 16, that means pk is also 16. Okay. And then we want to find the measure of the angle. So we have angle LZP. LZP is this angle right here that's in question. And I can use the same method I used before, 27 and 27, which means this entire angle is going to be 54 degrees. 31 and 31, which means this entire angle is going to be 62. So we can find this entire angle and cut it in half. So 62 plus 54 plus angle Z is going to equal 180. So that is 116 plus Z is 180. So when I subtract, Z is going to give me 64. So half of 64 is going to give me one of those angles, because that would be bisecting. So my angle is going to be 32.